Okay, so here is our study guide that was designed to help you prepare for your test on Unit 3C, which is basically roots and radicals. So, remember, show all your work to support your answer. Do not assume all variables are positive, so you got to remember the absolute value signs when we're working through these problems. Okay? So, we have to simplify, and to simplify and add terms together, we have to have like radicands. So I look at this and see if I can simplify these, and I'm looking for the largest perfect square factor. So when you get on the test, the first thing you want to do, each person will have a piece of scrap paper. Go ahead and write that chart down if you want to, or you can just use your calculator, either one. But 72 is 36 times 2, so this is going to become 6 square roots of 2 because 36 is a perfect square. Plus 32 is 16 times 2, and I'm just thinking of the largest factor, perfect square that I know that goes into that number. So that is going to become 4 square roots of 2. And 18, of course, is 9 times 2, and the square root of 9 is 3. And the 2 stays underneath because the 2 is not a perfect square. So when you have simplified it and you have like radicands, the exact same thing underneath your radical sign, then we just add the outside numbers. So 6 plus 4 plus 3, if there was a minus sign, then it would be minus 3. But 6 plus 4 plus 3 is 13, and my radicand doesn't change. This is those blob problems. 6 blobs plus 4 blobs plus 3 blobs is 13 blobs, and you don't change the blob. Okay? Similarly, um, I'm going to do the same thing. Okay? They're not the same, so I cannot combine them, but I have to see if I can simplify them. And 32, again, is 16 times 2. So if I take the 16 out, the square root of 16 is 4. And then I have the 5 and the radical 2. And then this one is 49 times 2. And the square root of 49 is 7. So when I bring this down, I bring down the 4. The order that you write these numbers doesn't matter because I am multiplying. But keep in mind, you do multiply these numbers, okay? The square root of 16 is 4, and it's going to be 4 times 5. The square root of 49 is 7, so it's 4 times 7. So that's 20 square roots of 2 plus 28 square roots of 2. 20 plus 28 is 48 square roots of 2. All right. Um, 625 to the 1/4, okay? I have asked you to show work for every problem. Yes, you can put it in your calculator just like that, but you need to also show me that it can be written as the fourth root of 625. So that would be the minimal work that you would write on that, and the fourth root of 625 is 5. If you do not know how to use your calculator, you need to be sure to come see me, okay? Number 4. So this one, um, I did this, but when I did it in class, and so I'm kind of going to do it this way. If you forget what to do on this problem, y'all, think of the 5s as x's. So this is x to the 2/3 times x to the 1/2. And when I have the same base, I add the exponents. So if I add those two numbers, use your calculator to add your fraction. That becomes 7 over 6, because 2/3 plus 1/2 is 7/6. And then that becomes the 6th root of x to the 7th. Okay? And I cannot leave a bigger number inside, bigger than the index. So everybody knows that this becomes 6 goes into 7 one time, and then I have the 6th root, and I have 1 left over. Okay, so that exact same problem, and if you want to work it that way, work it that way. Now, everywhere you see an x, you think that you have a 5. So this is my final answer that I have, so I'm going to write that 5 times the 6th root of 5. Same concept. Okay, so if that's easier for you to see and help you remember that you don't change the 5s, go for it. Do it that way. All right, 27 to the 1/3, 343 to the 1/3. Multiple ways to do it, but I'm okay with this point. You don't have to write it like that. You can tell me what the cube root of 27, but you should be able to write something down. And the cube root of 343, of course, is 7, and 3 times 7 is 21. Alright, this thing's blinking at me. It's bothering me. Alright, the cube root of 54. 54 is not a perfect cube, so I'm going to break it up into factors that I know are cubes. And a cube that I know that goes into 54 is 27, and that's 27 times 2. So the cube root, okay, a lot of y'all are ignoring that number, but that means the cube root of 27, that's 3, so this becomes 3 cube roots of 2. And then 16, the highest cube that I know goes in there is 8. And the cube root of 8 is 2, so this becomes 2 times the cube root of 2. So again, that's 3 blobs plus 2 blobs, and that equals 5 blobs. Okay? Don't forget the index on that blob, and that blob doesn't change. All right? So, real square roots. Okay? Whether it's square roots or fourth roots or sixth roots, if it's an even number, your answer will either be plus or minus, or no real number because it cannot take the even root of a negative number. Okay? So then I just take the square root of the top and the square root of the bottom. And make sure that doesn't reduce, because if it can reduce, you got to keep going. And again, put it in your calculator. There's the square root of that. Okay? You have a calculator. Use it. Okay? If you can do it in your head, that's great, but I'd love for you to check it on the calculator. All right. Here is cube roots. Okay? So I'm trying to highlight this so you can see the difference. Okay? Cube roots is an odd number. So it doesn't really matter what the number is itself. It matters that it's even or odd. And this one, you have an answer for anything. You never give me no real number. If it's negative to start with, then your negative will be your answer will be negative. And if it's positive, your answer will be positive. The cube root of 27, we've talked about, is 3. All right, the cube root of 64. Okay, again, if you need help on your calculator or make that chart when you start the test, the cube root of 125 is 5, and the cube root of 512 is 8. So those are my answers. All right, number 9. Find the real number root, okay? So these directions are different than those directions because these have a radical sign in them. So you'll never give me plus or minus unless I give you a plus or minus, okay? It's positive, my answer will be positive. The sixth root of 64 is, I hope everybody knows. What's the sixth root of 64? It's 2. Okay, again, use your calculator if you need help with that. Okay, the fifth root of a negative number is going to be negative. It's similar to, it's the fact that it's an odd, so if it starts off negative, the answer will be negative. The fifth root of 243 is 3, and the fifth root of 3,125 is 5. Uh, the fourth root of a negative number, I cannot take the even root of a negative number, so this is no real number. Do not give me no solution. I'm not solving an equation. This is an even root, but my negative is not on the inside, it's on the outside, so that's fine. And the fourth root of 256 is 4. So this will be negative 4. So let me come down a little bit. All right, so simplify each radical. Please don't make this any more complicated than it is. Okay? When you look at this, you look at it. The square root of 81 is 9. And then you have a 2 here, and 2 goes into 12 6 times. So it's 9x to the 6th. Okay? This is an even number. I don't need to worry about absolute values. Okay? On to number 14. I have the fourth root of 256. Well, we just did the fourth root of 256 right there. So that's a 4. And 4 goes into 36 9 times. And 4 goes into 7 1 time. And then it has 3 left over. So 3 stay underneath. And I have an index of 4, so I have to remember to write that index of 4. Then I look at these and I have an odd x, so I go back and see this is even and this is even, the index and the exponent. So I need absolute values on the 9. When I look at the y, the 7 is odd, so I don't need to have it on the y, just the x. All right. Next, the cube root of 81, okay? 81 is not a perfect cube, it breaks up into 27 times 3. 27 is a perfect cube, so I'm going to bring that 3 out. Okay, 3 goes into 6 two times, so all the A's come out. 3 goes into 10 three times, but I have one left over. Okay, so I am still dealing with the cube root, so I got to have a cube root up there. I took this out and I took this whole thing out, but I still have a number underneath and I have some B's. And how many B's do I have? 3 went into 10 three times with one left over, so I have just the one. Um, I do have an odd here, but my index is odd, so I don't have to worry about it. All right, moving along. 3 into 108. Okay, 108 is not a perfect cube. I'm going to divide it by 4. Ooh, there we go. So when I divide it by 4, that becomes 27 times 4. So there's my perfect cube. And this is a perfect cube. So that just lets you know there won't be any of those left underneath. Okay? So I take out the cube root of 27 is 3. 3 goes into 4 one time, so I have an x. 3 goes into 9 three times, so I have 3 y's out. And then I know I have something underneath. Again, still have a cube root. So I have a 4 left underneath. And how many x's do I have? 3 went into 4 one time with 1 left over. So that's what your answer looks like. I have odd exponents, but I also started with a non-index, so I'm not going to have any absolute values. Square root. Okay, so I'm looking back to the square root of 54. I want to know perfect square factors of 54, and that would be 9 times 6, because 9 is my perfect square. Neither of these are perfect squares, but they both will be able to come out. So the square root of 9 is 3. Oh, it keeps blinking at me. Um, 2, remember there's a 2 there. 2 goes into 3 one time. 2 goes into 5 two times. Okay, and so I have a square root left. And I have a number of 6. How many x's do I have? I have 1 because 2 went into 3 one time with 1 left over. 2 goes into 5 two times with 1 left over. So that's our answer. So it's not really a lot of work to show, but you got to know what you're doing, okay? I gave lots of references of IXL throughout this unit, so please go back to our Canvas calendar if you want to see what those are or need some help with them. Okay, so here I have the fifth root of negative 64. Is 64 a perfect cube? It is not. But however you wish to look at it, 32 is a perfect cube from your chart, or hopefully you know 2 goes into it, so you're figuring out how many 2's there are in there, and there's 6 of them. So for every 5, we get to bring one out. Okay, but also don't forget this negative. That negative is underneath. You're going to bring it outside with your answer. The fifth root of 32 is 2. 5 goes into 14 twice. 5 goes into 20 four times. And let's see what I have left over. I have a fifth root. I have a 2 left over. 5 goes into 14 twice with 4 left over. Unfortunately, there's no y's left over because I'm running out of room. So that's your answer. All right, number 19. Okay, simplify the expression. This is just multiplying. So when I'm simplifying this, y'all, you can multiply it out. 3 times 9 is 27. But you also might think that 9 is 3 times 3 times 3. And whenever I have 3 of something, I get to pull one out. So again, however you wish to think about that. But I'm going to follow that same concept here. If it's negative under with an odd, I know my answer is going to be negative. But I have the cube root. There's a 7, and 49 is 7 times 7. So again, I have 3 sevens, and I get to pull one out. Um, you can go ahead and multiply it out. There's nothing wrong with that, but then you just got to break it up again. So you got to find those factors. All right, look at 21. I have 2 times 8. Again, you can multiply it, but I kind of want to show you this. 8 is 2 times 2 times 2. So every time I have 2 of something, I get to pull one out. That means my answer is going to be 2 times 2, which is 4. Okay? Also, square root of 16. But if you understand this concept when the numbers get bigger, it makes it easier for you. Okay? All right, moving along to square root of 8 times 2, and that's that same thing we just had. So I'll go ahead and multiply it because I know that's an easy one to break up. That becomes 16x to the fourth. The square root of 16 is 4. The square root of x to the fourth is x squared. Um, because remember, when you multiply, you add the exponents. There's no addition of your terms. Okay? All right, looking at 23, I have a 5 on the outside, and then I've got my cubes in here. Okay? And I have 9 is 3 times 3, and 24 is 3 times 8. And then how many y's do I have? I have 3 of them. So I'm hoping you can see I got 3 threes, so I can bring one 3 out. 8 is a perfect cube. Cube root of 8 is 2, and 3 goes into 3 one time. So I have to multiply those numbers. 15 times 2 is 30, so this is going to be 30y. All right, hope you're good. If you have any questions, please don't hesitate to email me. Come see me. All right, whenever I have division or any kind of multiple numbers in mainly division, that's where we're going to see it, um, always try to simplify first. So 128 divided by 8 is actually 16, and we know the square root of 16 is 4. So we're good with that one. Okay, I'm going to simplify this guy. It is the cube root. 8 divided by 3 is 27. Okay, and we've talked about I have 5 x's on top and 2 x's on bottom. So I have more on top and I have 3 more on top than I do on the bottom. And I only have 3 y's on top. So now I'm taking the cube root of 27, which is 3. 3 goes into 3 one time, and 3 goes into that 3 one time. So my answer is just 3xy. Odd numbers, but I have an odd index, so I don't have to worry about it. So we're good. All right, so again, simplify this, and let's see what I get. I'm going to get, um, I do notice my variables aren't going to cancel, so I'm going to have still a fraction. I'm on the fourth root, but 162 divided by 2 is 81. I still have x to the fourth, and I have y to the eighth. And all of those are perfect fourth roots because the fourth root of 81 is 3, and the fourth root of x to the fourth, 4 goes into 4, is 1. And the fourth root of y to the eighth, 4 goes into 8 two times. I have an odd exponent. My index is even and my exponent is even, so this one actually needs absolute values on it. Okay, moving along. I have here the square root of 8 over 6, so I'm going to think to myself that divide the top and bottom by 3, and that gives me 4 over 3. So I need another 3 on bottom to not leave the radical in the bottom or leave a fraction in the radicand. This is a perfect square that comes out, and this is a perfect square that comes out on the bottom. So on the bottom I have 3, the square root of 4 is 2, and then that 3 has to stay under because I didn't circle it. So that's our answer there. Okay, this one, there's nothing in the bottom that prevents you, but the top actually becomes, that's the square root of x to the fifth, so 2 goes into 5 twice with 1 left over. So it looks like this, 8x squared, and my x squared, I have 1 on the top and the bottom, so they go away. And that leaves me with the square root of 3x over 8. And that's simplified. I don't have a fraction in my radicand, and I don't have a radical in the bottom. Okay? 29. So I'm going to simplify that again, as I keep saying. So on the top, let's see what we got. The 2 stays down here. Actually, I want to write it a little different. Let's go with one whole big one. And that means I'm going to have the 1/2 out here, and I'm going to have a cube root. And 6 and 5 don't cancel. Um, 2x's on top, 7x's on bottom leaves me with 5x's on bottom. 4y's on top and 1y on bottom leaves me with 3y's on top. Okay, so I have to make this thing a perfect cube because I'm dealing with cubes. So that means I need to see those factors 3 times or multiples of 3. So I have 1 5. I need 2 more 5's. I have 5x's, but 3 doesn't go into 5 evenly. So the next multiple up would be 6. I need 6x's because 3 goes into 6 evenly. So that means I need another x on the top and the bottom. So on the bottom, if you can see that, I'm just going to write what's on the bottom. That means I have 3 5's and I have 6 x's. That's what that is. Okay? I'll go ahead and write the whole thing so y'all can see it. And on the top, 6 times 25 is 150 and xy cubed. Okay? So I'm just writing, if you want to multiply that out, that simplifies it for some. But what does this become? Well, that on the bottom, that gives me 5x squared because I have 3 5's. I get to bring one out. And 3 goes into 6 twice. So that's my denominator. Oh, ho, ho. Forgot that little 2 right there, y'all. So it's 1 times 5 times 2. Let me go. So that should not be a 5. It should be a 10. Because when I bring that 5 out, I have to multiply it by the 2. Put equals in there. And then on the top, the only thing that comes out is this y cubed right here. So that gives me a y. And then the cube root of 150x. So that's my answer there. Can't do anything with those because this is inside the radical and that's outside the radical. All right, back to some numbers, okay? I have to make these radicands look the same. So 27 is 9 times 3. It's square root, so I'm looking for perfect squares. The square root of 9 is 3, so this is 10 times 3 root 3. And then 12 is, of course, 4 times 3, and the square root of 4 is 2, so this becomes 4 times 2 root 3. So I have 30 blobs minus 8 blobs, which gives me 22 blobs, and my blobs happen to be the square root of 3. All right, let's see if I can squeeze this next one in here. Same thing that we've been doing. So I'm going to simplify. This is going to be 4 times 5. So that's 3 times 2 root 5, and the x has to stay under. I can't take the square root of that. Plus, this is 9 times 5. So that's 8 times the square root of 9, and again, 5x. And then, oh, I don't have to do anything with that one. That's nice. But again, I have my blobs. That's 6 blobs plus 24 blobs. 6 plus 24 is 30. Minus 4 blobs. And 30 minus 4 is 26 blobs. And my blobs are the square root of 5x. Make sure that you extend that radical over your whole radicand, because sometimes people don't put things in the wrong place and it can be misconstrued. Okay, cube roots. Again, my radicands don't look exactly the same, so I'm going to simplify them, but I'm looking for perfect cubes. So this time it's 27 times 2. Ooh, I can take that out too. So this is a perfect cube, and that's a perfect cube. So that's 3x times the square root of 2. Let's hope the same thing happens over here. That's 8 and 2. And 8 is a perfect cube, as is that guy. So this gives me minus 2 square root, cube root of 8 is 2x radical 2. So I have 3x blobs minus 2x blobs gives me x blobs. And my blobs is square root of 2. Oh, it's not the square root of 2. It is the cube root of 2. There we go. All right. Moving along, there is no addition or subtraction, so this is a multiplication problem, and we're going to FOIL. The first terms, 3 times 4 is 12. The outside term is 3 times the square root of 2, so that's plus 3 square roots of 2. The inside terms plus 4 square roots of 2. So when you're multiplying these things, y'all, if it's not under a radical, don't put it under the radical. If it's under the radical, you got to keep it under there. And then the square root of 2 times the square root of 2 is 2. So 12 plus 2 is 14. And then 3 root 2 plus 4 root 2 is 7 root 2. All right, this is our a plus b, a minus b. So you square the first one, subtract, and you square the last one. They both have radicals in them. If there was no radical, then it would just be, you would be 5 squared. And 5 minus 11 is negative 6. So we're good. Another one, we'll keep going. All right, it's not a plus b, a minus b, so I'm going to do the FOIL thing that I did. 10 times 10, first terms is 100, minus 10 times the square root of 3, plus 10 times the square root of 6, and minus, um, this I'm going to look at it as 3 times 2. So when I multiply it times that, I know that a 3 can come out. Now, if you don't like that, do 6 times 3, 18. 18 is 9 times 2. Square root of 9 is 3. So however you wish to look at it. I just have a habit of breaking it down before I multiply it together. So that actually cannot be simplified. There are no like terms of anything, so I have to squeeze this in here. Minus 10 square roots of 3 plus 10 square roots of 6 minus 3 square roots of 2. Okay, moving along. 2 plus the square root of 5 over the square root of 5. Okay, pay attention to the difference between these two, y'all. Okay, this has a plus sign on the bottom. This one does not. So all I have to do is multiply by the square root of 5 over the square root of 5. And I would distribute it because this is a binomial. So on the bottom, I just have a 5, because square root of 5 times square root of 5 is 5. But on the top, I get 2 square roots of 5 plus square root of 5 times square root of 5 is 5. So it looks like that. And please do not cancel those out. The 5 has to go into this and this to be able to cancel it. So just leave your answer like that and we're good to go. All right, so this one, I'm going to multiply by 1 minus the square root of 8 over 1 minus the square root of 8. So on the bottom, I know that y'all are all pretty good at that. That's my square the first term, subtract, and square the last term. So it ends up like that. But what we have on top is 3 times 1, first term, outside terms. That's going to be 3. I'm going to go ahead and write it like this. 3 square roots of 8. Inside terms plus the square root of 18. And the last terms are going to give me, I'm going to go up here with it, minus, I am not multiplying that out. So that is 18, which is 9 times 2. And then 8, which is 4 times 2. So I'm doing that because that's going to be easy when I simplify that. All right, so on the bottom, I have negative 7. And on the top, this, if you notice, 9 is a perfect square. So this is going to be 3. 9 is a perfect square. 4 is a perfect square. Square root of 4 is 2. And then I have two 2's, so I get to bring one out. So that's 3 times 2, which is 12. So I have 3 minus 12, which is negative 9. And then I have these two things that I need to simplify and see if they can combine. So the square root of 8 is 2 square roots of 2. And the square root of 18 is 3 square roots of 2. Because that's 9 times 2. So 9 times 2 gives me 3 square roots of 2. This is 4 times 2, which is where I get 2 square roots of 2, but I had a 3 outside. So this is 6 square roots of 2, negative 6 square roots of 2, plus 3 square roots of 2, And negative 6 plus 3 is minus 6 square roots of 2. Now, that's an acceptable answer for now, but generally because there's a negative in each term, I would multiply top and bottom by negative 1 or divide top and bottom, however you wish to think about it, which has the effect of changing the signs. So, oh, I didn't write what I told y'all. Okay? It's because y'all aren't here. I said a 3 because it was minus 6 plus 3. And minus 6 plus 3 is minus 3. So then when it becomes plus, it becomes 3 square roots of 2 over negative, I mean, positive 7. They all got changed because I multiplied everything. Multiplied top and bottom by negative 1. But like I said, if you don't want to do that, you can leave it all like that. I'm fine with that. All right. Sorry about that mess there. X to the 1/4 to the 4th. When you raise a power to a power, what do you do to those exponents? That's 1/4 times 4, and 1/4 times 4 is 1, so that's just x. Okay? This is the same thing as the cube root of negative 8y to the ninth. So the cube root of negative 8 is negative 2, and the cube root of y to the ninth is y to the third. So that wasn't so bad. This guy, because I have a radical and an exponent and everything, I'm going to simplify him first, and we've talked about that. So I'm going to simplify everything in here. The square root of 9 is 3. The square root of x, I'm going to write that as x to the 1/2. And the square root of y squared is y. And then I raise it to the 4th. And when I raise it to the 4th, there's no plus in here, so or minus, so I'm going to distribute it. So it's going to end up being 3 to the 4th, and then x to the 1/2 to the 4th, and I multiply those, and then y to the 4th. So when I simplify that, it's going to 3 to the 4th is 81. 1/2 times 4 is 2, and then y to the 4th. So that's what our answer looks like. All right, we are almost done. I know it's been a long one, but hopefully it's been helpful. All right, so on to the next one. I'm going to multiply them. Again, raising a power to a power. So 1/6 times negative 18 is negative 3. And 1/3 times negative 18 is negative 6. You cannot leave a negative exponent, so I just put it in the bottom and make them positive. So that's 1 over x to the third, y to the sixth. Here I have an x on the top and the bottom. I'm going to simplify that first. So when I have x to the 4th over x to the negative 1, however you wish to think about it, but you subtract those exponents, and that gives you x to the 5th, because it's 4 minus a negative 1 to the negative 1/5. I multiply those, and that gives me x to the negative 1, and I can't leave x to the negative 1, and that becomes 1 over x. Um, okay, again, I can't simplify this, so I'm going to go ahead and distribute the negative to both. So I have 1/3 times negative 9 is negative 3. And negative 2/3 times negative 9 is positive 6. Just use your calculator to multiply those two. Can't leave a negative exponent, so I'm going to put them in the bottom and make them positive. So that becomes 1 over x to the third, y to the sixth. Okay, on to solving equations. We're on the down home stretch. Okay, always want to isolate that radical first. So now I'm going to square both sides. Okay, and when I square this, I get just x minus 3 because my radical and my exponent cancel each other out. This is our little thing that we've talked about so much. Okay, so I'm going to write it again here. So a minus b quantity squared is a squared minus 2ab plus b squared. Okay? You multiply the terms to get that middle term. Y'all know to square the first and the last, but to get the middle term, you multiply them together times 2. So, that being said, if it's minus, it's minus. If that were plus, it would be plus. So if we have that, you'll see. So I square the first term, multiply them together times 2. So x times 5 is 5x times 2 is 10x. I don't change that sign. And then I square the last term. 5 squared is 25. I have my quadratic. So I'm going to take everything to one side like we've been doing. 0 equals x squared minus 10 minus 1 is minus 11x. 25 plus 3 is 28. Okay? Pause if you need to. Come back. X minus 4, x minus 7 is how that factors. So when I set each factor equal to 0, x minus 7 equals 0, then I find out that x equals 4 or 7. I'm going to write it here because I actually need to check. So if I put 4 in, 4 minus 3 is 1. The square root of 1 is 1. But 4 minus 5 is negative 1, so that doesn't check. 7 minus 3 is 4. The square root of 4 is 2, so that side I got a 2. And 7 minus 5 is 2. So I have just x equal to 7. All right. 2 to this blob. 2 times that blob equals 16. I'm going to get rid of that 2. So x minus 1 to the 3/4 equals 16 divided by 2, which is 8. Okay, and now I am going to raise it to the power suggested by my index. All right, and I'm going to actually raise this to the 4/3. So I'm going to raise this to the 4/3 because I got to do the same thing to both sides of my equation. So when I do it over here, that gives me 1 because any number times its reciprocal is 1. So x minus 1 and 8 to the 4/3. Put it in your calculator if you need to, but I'll tell you how to do it without it. You take the cube root of 8 because that's your root. Cube root of 8 is 2, and 2 to the 4th is 16. Now, remember if either one of those had an even number, we had to put absolute values around it. So we get absolute value of x minus 1 equals 16. So that tells us that x minus 1 equals 16, or x minus 1 equals negative 16. And so I add 1, that means 16 plus 1, and I add 1 to this, and I get negative 15. Okay? And you go back and check those, and when you check them, you will find out that negative 15 does not work because you can't take the fourth root of negative 16. So x equals 17 in this case. And if you have any problems with that checking, okay, please come see me. All right, last two. Again, you want to isolate that. So we're going to move that 1 to the other side, and that's going to give me x plus 3 equals x plus 1. Okay, and I'm going to square both sides to get rid of that radical. And I'm writing it like that so you can hopefully remember that that's that binomial thing that we have to square that we did. We have to do this to that thing again. So this is going to be x plus 3. Then I square the first term, keep the sign, multiply them together, times 2. 1 times x times 2 is 2x. And then I square the last term. And that lovely quadratic. So I'm taking everything over to one side. So 0 equals x squared. I subtracted x. So 2x minus x is plus x. And I subtract the 3. So 1 minus 3 is minus 2. Pause if you need help. If you want to try to factor it yourself. That becomes x plus 2, x minus 1. And so I set each factor equal to 0. X plus 2 equals 0, and x minus 1 equals 0. And so that tells me that x equals negative 2 or positive 1. And I'm going to check. Negative 2 plus 1. No, negative 2 plus 3 is 1. Square root of 1 is 1. And 1 minus 1 doesn't equal negative 2. So that guy doesn't check. If I put a 1 in there, 1 plus 3 is 4. Square root of 4 is 2. 2 minus 1 equals 1. So I got x equals 1. All right, last problem. Oh, I got 2 of them. So I need to take this guy to the other side because he's just a little simpler than that one. So that's leaving me with 5x plus 1, square root of 5x plus 1 equals 1 plus 2 square roots of x. So I am going to square both sides. Square it. And square it. So on the left side, I get 5x plus 1. And on the right side, I square the first term, keep the sign, multiply them together, and then times 2. So that's 4 square roots of x. And then I square the last term. When I square that thing, I have to square the 2, and square the radical. So that's what I get. And now I want to isolate this guy. So I'm going to take the 1 over, and I'm going to take the 4 over there. So 5x minus 4x is x. And 1 minus 1, those go away. How nice. And that leaves me with 2. Nope, not 2. I was looking on the wrong line. Leaves me with 4 square roots of x. And I'm going to square both sides. And so x squared is x squared. Got to square the 4 and the radical, so you get that. Quadratic, we got to bring everything to one side, so I'm going to subtract that 16x. In two terms, always look for that GCF first, so that's x times x minus 16. And that gives me x equals 0 and x minus 16 equals 0, which gives me x equals 16. And just for the purpose of the video, and we're so long, we've been here 40 minutes at least, um, they both check. So that's your answer. If you have any questions with your calculator or any of these problems, please come see me.